All right. So this video tutorial is going to be a brief introduction into threads and threads in the context of game programming. Threads is an extremely complicated topic. You could read an entire book or write an entire book covering threads and synchronization issues and stuff like that. So I don't want you to get the false idea that I'm going to go into that much detail. But if you've never seen threads before, this might be a good place to get started. Also, I just don't think there's enough material out there to cover threads, especially threads in the context of game programming. So let's get started. All right, so first let me kind of review what a single thread of execution is. So a single thread of execution is basically one line, linear line, that executes the program in sequence, statement by statement, or instruction by instruction until it gets to the end of the program. In this example, we have main. Main calls function 1, function 2 calls function 3, and so forth until you hit the end of the entire program, return from main, and that's the end. The basic, easiest way to explain what a single thread of execution means is that if you were to pause the program, hit the pause button in Xcode or Visual Studio, at any given point, the program can only be in one place at one time. So for example, if I pause it, we might end up in the middle of executing function 3, and usually it'll show a line indicating the instruction pointer or basically where the program is, and it'll always be stuck on one statement, and at a finer granularity, really one instruction inside the single thread of execution. When you have multiple threads of execution, what you do is you add another line through your program. It's almost like you're running two programs at once, but the threads are running still inside your program. They access the same memory, they can call the same functions. For example, notice there I have function 4 both being executed at some point in main and some point in the thread function. Not that that necessarily would be a good idea, but I just wanted to show that's possible. So basically we have one line now going through main and another line going through some arbitrary function which executes the thread. I just called that thread main. And thread main calls function 5, then 6, and then 4 calls some read function, and so forth. So the difference from what we had before is that if I have more than one thread in the program and I pause the program, you will now see that basically the program can be in two places at once. Each thread can only be in one place, but if there's multiple threads, the program can be paused in each thread can be in multiple places at the same time. So in this case, I'm paused. The main thread is stopped in the middle of running function 3, and the second thread, or just the other thread, is stopped in the middle of executing function 6. So there's the example of that. Let me explain kind of how threads are created, because you don't just have a thread out of thin air, you have to create them. So typically all programs at the simplest measure are one thread. Usually they remain that way, but if you want to create a thread, what happens is you have some function, you have some sequence of events that happen in the main thread, and at some point you decide you want to create a thread, you want to utilize the thread for something. So you have some function that creates a thread for you. That's not a standard function, thread create, I just named it that to make it easy to explain. Once you create a thread, your program will fork into two threads of execution. So basically thread create will basically return to the main thread and then call some thread function, which I call thread main, could be called anything you'd like, and then start executing the thread and the thread function and then continue on usual in main in the main thread. So basically what happens is the main thread now will continue after thread create and call func 3 and func 4, and the threaded function, or the secondary thread will run thread main and then call do work and so forth until it returns from that thread main. Once a thread returns, or the main thread waits for that thread to return, thread join will basically occur and the thread life cycle will end. So basically we have this single thread of execution forks into two threads. For a brief period of time the program is multi-threaded, and then when the thread exits, it is rejoined with the program, and the program becomes single-threaded again. It's important to state that that doesn't have to happen. So I just went back a slide here. It can remain multi-threaded until the entire application exits. Basically, if one thread requests to exit the entire program, then that's the end of the program. But I find it's more tractable that if you can, this is the most simple and least complicated style of threaded execution. While your program has multiple threads, it can be very, very complicated and a lot of things can go wrong, which I'm probably going to elaborate on going forward. So you want to have the multiple threads existing as brief as a time as possible so you can avoid things going wrong. So the way I like to do it is keep things in a single thread, very simple, fork to create the thread while I need it, and then the minute the thread is done, rejoin the program. And you can see just even this diagram kind of makes things just look simple and tractable. So when should you use threads? The simplest case I can think of when you would want to use threads is when you come across something called blocking I/O. So I/O is any input-output from anywhere. It could be input-output to the disk, it could be input and output to another machine via a network connection, and if that input or output does not finish in some reasonable amount of time, it will block the thread that called it. So for example, if you only have one main thread, and that main thread is doing something rather important like a game loop, and then you initiate a network connection, and that network connection blocks your thread until the server responds, your game will freeze while you're waiting for that connection to finish. Or if you decide you want to load a 4 GB file, it might take a little while for that to finish, and the default mechanism for reading from a file is that it will block until that file is finished, because when that function returns, you assume all the data is ready. So that's a case where you might want to use a background thread. Heavy computation is another one. So suppose you have an algorithm where you're detecting if a bullet is intersecting one of millions of polygons in a scene. That might take a while to compute, and if you can wait, if it's acceptable to you to wait for the result of that computation, then maybe that's something you decide to do in a background thread. And of course, if you have something like 4 cores on your CPU, you can easily utilize one of those cores in a background thread without hurting the performance of your main thread that much. So just tying this up, you probably always want to avoid, I always say that you should always avoid using threads if possible. If there is a way around them, and you really thought hard about it, and you could find a way around them, you should avoid them, because once you introduce threads into your application, you essentially are inviting a whole treasure trove of problems that can crash your program. Even the most experienced programmers, myself included, when they're using threads, will sometimes come across something they just weren't planning on to happen, because it's complicated to think about multiple threads of execution through your program at the same time. You can introduce a lot of bugs. So basically, threads should be a last resort, because once you introduce them, lots of things could go wrong with respect to synchronization and stuff like that. Nonetheless, I'm going to go ahead and run through an example with you guys of a use case of blocking I/O when you would like to use a thread, and I'm going to show you kind of how they work. So I have an Xcode project I'm going to pull up here, and it's basically a version of my game that I went through and created when we did the game programming series. However, I've added some kind of crazy stuff to show an example of where you might want to use a thread. So what this game does is basically I've added this stupid banana block, and this banana block, when you bump it, will initiate a Google image search and will download a random image of a banana and insert it into the game. So I'm just going to show you what happens when they do that. Sometimes the network connection might fail. So there's an example of a random banana I pulled off of image, Google Images. So every time I hit it, I'll get a different one. If the network connection fails, maybe I'll get the same one, but you get the idea. But what you're probably noticing immediately is that when I hit this block, the game will freeze for however long it takes for whatever server I'm downloading the banana image from to respond. If it's a slow server, it could take forever, and basically it blocks the main thread, which is running the game loop. Now, as a game programmer knows, it is very bad to freeze the entire game up while you pause the game loop. The game loop should always be doing things that are immediately respond and immediately finish, so that you don't lower the frame rate of the game or cause the game to pause while you're doing some heavy intensive work. So this is a candidate of an example of blocking I/O where you would actually like to use a thread, and I'm going to show you how. So let me show you the part where I actually call the download. So I just have this start download function, which I call when I bump my head on the banana block. And basically it calls download, which is the function that basically does the entire download for me synchronously. And then get local file returns the local file name of where the downloaded file is, which I just put somewhere in a temp file, temp directory on my Mac. And then of course I just do the standard SDL. I've shown you guys this in previous videos. Load the image into a texture, and then you have it. And then I do some animation stuff to scale it out above the block. But basically, this is the part that this function download is the function that blocks the thread. This does not return until the image has been downloaded. So I went ahead and put those routines in another module called download. And this is some pretty bad code because I just wanted to get it to quickly do a blocking download. I just used libcurl to perform a Google image search and then download the file here. But basically, this function download will not return until the file is downloaded. That's the point I want to make. Another thing I want to say real quick is I'm using C++ here because this is one of the few cases where there is not a standard API, at least built into C, to do threads. You kind of, when you want to do threaded programming, you kind of have to do it differently on Windows versus Mac versus Linux. And while there's a couple APIs I could use, I just find it easier that C++11 has threads built in, and they do it in a very nice fashion. So I'm going to go ahead and use C++, namely the new C++11, to create these threads. So the first thing I did is, or I'm going to do, is I include thread, and then I include atomic up in my header includes. I'm going to explain what atomics are in just a second, but they're important. And I haven't done this. I haven't really planned this out, so this might go wrong as usual, but we'll see. And I'm going to create a thread. So what I'd like to do is have my thread function be download. So basically, I'd like to run download as my thread main in the background thread, and then when it's finished, I'd like to notify the main thread that a file is ready to be downloaded. So the way you declare a thread in C++11 is you just do standard thread and then the name of the function you want to run in the thread. And the minute you do this, once you declare it, essentially the thread is going to run once you've done that. So it succeeded. Now I think the biggest problem with this is when the thread deinitializes, when it goes out of scope, I think it will try to join with the program, which could cause it to pause. So I think a better optimal way to do this actually would be to store the thread outside of here as kind of an entity that I can keep track of outside of the scope of this function. So just for the brief example, or case of example, I'm just going to declare it up here. And I'm going to declare it as a pointer so that it's not immediately created. And then I can kind of control when I want to delete the thread and cause it to join with the program. So I'm just going to call this download thread, and I'm going to initialize it to null. So there's my thread, or at least my thread pointer. So when I want to actually call download, what I'm going to do is I'm going to set download thread equal to a new thread that calls download, the function. And at that point, it should start the thread. And only when I'm ready to join with the program, basically join the two threads to main, am I going to delete this thing. So what I'd like to do at this point is have some variable that can tell me when the download is done that I could set from the download code. So I have this game state struct because a lot of this stuff is still C. And what I'd like to do is basically include atomic here and declare what's called an atomic int inside the game state data. And this will basically be called download state. Do I have another thing called download state somewhere? No, I don't. Now you're probably wondering why I declare this as an int and not, or as an atomic int and not a regular int, and I'll explain that. The basic gist is when you're working with multiple threads should be very, very careful that they always work on their own data and don't touch the same data at the same time in the same program. If they do that, they can basically put the program in an inconsistent state. And this has a lot to do with the way the individual assembly instructions are composed when you do operations like incrementing an integer, decrementing an integer, setting an integer, and all that stuff. So what an atomic variable does is it prevents you, or allows two threads to to access the same variable at the same time in a way that's consistent, so that if one thread is trying to access it while the other one is, the first one will have to wait and get in line to access that data. So the general gist is that if you ever have two threads and you want them to be reading something while the other one's writing it, there's multiple ways to handle this. The simplest way to handle it is the atomic data types. I could cover so many other ways, but this video would go on for hours if I did. So we're going to utilize atomics to do this. So what download state's going to do for us is it's going to have three states. It's going to be called download ready, which basically means we're not downloading anything. It's going to be download started, which basically means we are in the middle of downloading, but we're not done. And we're going to have download ready is actually terrible. I should basically say download idle. Download finished means that we've completed a download. There's a file ready to be used by us. And these are going to be the three states that basically this atomic download state is going to be in. So let me just build and make sure I didn't do anything wrong here. Okay. So during the initialization, what I would like to do is access my download state and call something called store on it. And what store does, it allows me to atomically store the value inside the atomic. Now granted, we're single threaded at this point. It's very unlikely something can go wrong. It's just good practice to use these load and store functions when you're accessing the atomic at all times. So I'm storing 0. Actually, that's stupid. I should use my own. So I'm starting it as idle, right? So during my game loop, what I'd like to do here is I'd like to take this code that actually reads the downloaded file and put that in a function called read download, and have that ready to call when we're sure the file is downloaded. And what I'm going to do is inside the process function, which is called once per loop, I'm going to check to see if the download is ready, and if it is, I'm going to call that function. So if game download state load is equal to download finished read download. Now this will only ever be true if I have set it to download finished from, I'm just going to move these. It'll only ever be true if I've set it to the state download finished from the background thread, because that's the only place where I'm going to be setting that condition. So basically we're all right there. And there's one more case where I'd actually like to be a little careful here. When I call start download, which happens when I bump the block, ideally what I'd like to do is set the block to a red color and leave it as a red color while I'm waiting for it to download. That way if you keep bumping the block and you're waiting for one download to finish, I don't start like 100 downloads in 100 separate threads, because that could become a problem. So what I'd like to do in this case is if the download state is not idle, don't do anything at all. That way you can keep bumping the block while you're waiting for the first download to finish and nothing will happen. That's pretty important. One last thing that just popped into my head is, of course, when the download's finished, I should set it back to idle, because basically that means we're ready to do it all over again. So we're almost ready to run this here. The most important thing, though, is actually the notification from the background thread. Actually, another thing I need to do here is I actually need to, at this point the thread is dead to us too, so what I'd actually like to do is I'd like to take the download thread, call join, and then delete it, and then set it to null for good practice. So this will be the point where the thread rejoins with the main program. Once the download's been finished, we utilize it, we set everything back to idle, and we're kind of back in the state we started from. So that's good. You can see there's a lot to think about when you're doing this. Even the most simplest example of this, you got to really cover your edge cases here, and you got to think pretty hard. So now that we've got everything we need done from the main thread, I do think we're ready to jump to the download thread. I just want to make 100% sure. Oh, that's right, the red. So I set this to red when it's downloading, and then to get it back into the consistent state, once the file has been downloaded, I set it back to regular color. So we're ready. Inside download, this is the code. This function now will be basically the thread main. It'll be the function that's running in its own thread. It's important for me to now pass it some information that it's going to need to access the game state. So basically I'm going to include main here, and I'm going to pass game state as an argument to download. Okay, so there's download. Basically what we're going to do here is we've initiated the download, and when this is finished we are going to notify everything that it's ready. We're going to notify the main thread that we're ready, so basically we're going to store download finished when we return from this function. And that's the atomic store for that, so I think we're actually good. There we go. So basically I call thread. I call it with multiple arguments, and the second argument is going to be the argument to the thread function. So if I go ahead and run it, I should get some asynchronous downloading occurring. And of course, you can see now, while I'm waiting for the download to finish, I can still move around. So while the block is red, the background thread is active. And when it's not red, it means that we've rejoined back. So basically, asynchronous network connection running in the background thread, and then it notifies that the download is ready and we're good. So I think this is probably a good stopping point here. I know that this probably wasn't explained the best it could be explained. Threads are a very complicated thing, but you could see the utilization here. I mean, how useful it is to be able to do something like this. So this code might have a few issues running on Windows because of certain decisions I made, but if you guys would like, I can upload the Xcode project and put that available for you guys to download and play with in Xcode. So, as usual, thanks for watching, guys. If you like this kind of stuff, go ahead and like and subscribe and let me know. And I will see you guys during the next tutorial.